Assalamu alaikum students. In question number 4, we are required to simplify and write your answer in the form of a plus b iota, the standard form of complex number. In this question, we deal with the rational form of complex number. Rational form means the complex numbers are present in somehow in a fraction. So the solution of such kind of question lie in rationalization of the denominator, and how we rationalize it, we simply multiply by the conjugate, because we already learn in question number 1, the product of the two complex number is always a non-negative real numbers, and we verify it as well. So let's use this phenomena. In this question, minus 2 over 1 plus iota, we multiply and divide by the conjugate of the denominator, 1 minus iota divided by 1 minus iota. Numerator is multiplied to the numerator, minus 2 into 1 minus iota divided by 1 plus iota into 1 minus iota. Minus 2 1 minus iota will remain as it is. Why? We come to know in the next steps. In denominator, we apply formula a plus b into a minus b, that is equal to a square minus b square. Minus 2 1 minus iota will remain same, and 1 square is equal to 1, and minus, putting the value of iota square, that is minus 1. In the next step, we have minus 2 1 minus iota, minus minus plus, so 1 plus 1. Minus 2 1 minus iota divided by 2, 2 is cancelled by 2, minus remain there. We multiply minus 1 minus minus plus iota, that is the simplified form of part 1 in standard form a plus b iota. Let's move to the part 2. In this part, we multiply by the conjugate of the denominator 4 plus iota and divide as well. Why we multiply and divide? Because we only need to rationalize the denominator, and if we multiply having the value in denominator 4 plus iota, that equation does not satisfy. Hence, we have to write in numerator, mean we have to multiply as well as divide. We use here the property of multiplicative inverse. In the next step, 2 plus 3 iota is multiplied to 4 plus iota, mean numerator is multiplied to the numerator, and denominator 4 minus iota is multiplied to 4 plus iota. 2 is multiplied to 4 plus iota, whereas 3 iota is multiplied to 4 plus iota, mean first term is multiplied this expression, and then second term is multiplied to this expression. The general principle of multiplication we use over here. In denominator, we apply formula a plus b, a minus b is equal to a square minus b square, and according to which we get 4 square minus iota square. 2 4s are 8 plus 2 iota plus 3 4s are 12 iota plus 3 1s are 3 iota square. In denominator, we get 16 minus iota square, put the value, that is minus 1. 8 coefficients are added, signs are same, 2 12 14 iota plus 3, value of iota square is minus 1, we put over here. 16 plus 1, minus into minus plus 1, so therefore we write plus 1 over here. 8 plus 14 iota minus 3 over 17 is equal to what? 8 minus 3, that is 5 plus 14 iota over 17. We apply the inverse action of taking LCM. We write each numerator along with the denominator, 5 over 17 plus 14 over 17 iota, and that is the simplified form of this question in standard form. Let's move to the part 3, that is similar to the part 2. We multiply and divide by the conjugate of the denominator, 3 minus iota over 3 minus iota. Numerator is multiplied to the numerator, whereas denominator is multiplied to the denominator. We find the product in the numerator, 9 into 3 minus iota, minus 7 iota into 3 minus iota, whole divided by, we apply formula on the denominator, 3 square minus iota square. 9 3 is 27 minus 9 iota, minus 7 3 is minus 21 iota, minus minus plus 7 iota square. 3 square is equal to 9 minus, put the value of iota square, that is minus 1, 27, minus 9, minus 21. Signs are same, we do addition, minus 30 iota it becomes, plus 7 iota square, we put the value equal to minus 1. 9 plus 1, 27 minus 7 will be equal to 20, minus 30 iota it will become, 9 plus 1, 10. Applying inverse action of taking LCM, we have 20 over 10 minus 30 iota over 10, and finally what we get, 2 minus 3 iota, which is the simplified form and also the standard form. We continue the question number 4, in which we are required to simplify and write our answer in the form of standard form of complex number. Let's begin with the part 4, in which we observe that we have two fractions in difference form and both have same denominator, and we generally know the idea of the same denominator, that if we have same denominator in two fractions, when we take their LCM, we write the numerator as same as they are. Like this, 3 plus iota will be the LCM, common factor, and numerator are written as same as they are, minus 4 plus iota. We open the bracket, 2 minus 6 iota minus 4 minus plus minus iota divided by 3 plus iota, that is equal to 2 minus 4 minus 2 minus 6 minus minus 7 iota divided by 3 plus iota. Now we start the process similar to the part 1 to 3. Minus 2 minus 7 iota divided by 3 plus iota. Multiply by the conjugate of the denominator, that is 3 minus iota divided by 3 minus iota. Numerator is multiplied to numerator, minus 2 multiplied to 3 minus iota, minus 7 iota is multiplied to 3 minus iota. In denominator we apply formula, 3 square minus iota square. Minus 2 is multiplied to 3 minus iota becomes minus 6 minus minus plus 2 iota, minus 7 3 is a minus 21 iota, minus minus plus 7 iota square. In denominator we have 3 square 9 minus iota square, we put the value minus 1. Minus 6, 2 minus 21 will become minus 19 iota, plus 7, put the value of iota square, that is minus 1, divided by 9 plus 1. In the next step, minus 6 minus 7 plus minus minus 7 minus 13 minus 19 iota divided by 10. Applying the inverse action of taking LCM, we get minus 13 over 10 minus 19 over 10 iota. That is the simplified form in the form of a standard form of complex number. Part 5. In part 5, we have a different scenario. In this we have a fraction in a square form. We have variety of solution, but we use this one, we apply the law of power fraction. By doing this, 1 plus iota whole square 1 minus iota whole square we get in the next step. Applying formula on numerator a plus b whole square, we get 1 square plus iota square plus 2, value of a is 1 and value of b is iota. In denominator we apply formula a minus b whole square, and that is equal to 1 square plus iota square minus 2, value of a is 1 and value of b is iota. Now simplifying it, we get 1 plus iota square, put the value, minus 1 plus 2 iota, divided by 1 square 1 plus iota square minus 1 minus 2 iota. Open the brackets, 1 minus 1 plus 2 iota over 1 minus 1 minus 2 iota. Like term, different sign, cancel, 1 minus 1, 0. Only we left 2 iota divided by minus 2 iota. 2 is cancelled by 2 and 1 iota is cancelled by iota. We get what? Minus 1. We use additive identity 0. That will facilitate us. How? Because we can write as 0 iota. So hence this is the standard form of this question. Minus 1 plus 0 iota. In part 6, we observe the two complex number in product form. So we multiply first. 2 into 1 minus iota plus 3 iota is multiplied to 1 minus iota. 2 ones are 2 minus 2 iota plus 3 iota plus minus minus 3 iota square. 1 over 2, 3 minus 2 plus iota minus 3, put the value of iota square, that is minus 1. 2 plus iota minus minus plus 3, it becomes 1 over 5 plus iota. Multiply by the conjugate and divide it. 5 minus iota, applying formula a plus b, a minus b is equal to a square minus b square. 5 square minus iota square we have. 5 minus iota divided by 5 square, 25 minus iota square is equal to minus 1. 5 minus iota, 25 minus minus plus 1, 26. We apply the inverse action of taking LCM. 5 over 26 minus 1 over 26 iota, that is the standard form of the complex number for this question. Thank you.